Hello! Thank you for choosing to attend this lecture. Today I will introduce a device which can replicate the sounds of many instruments. Not only can it reproduce the sounds, but I will demonstrate how it can play them simultaneously, as if a chamber ensemble were playing right here in this room. The wonder of this instrument does not stop there. No, because the complexes of gears and levers work together so ingeniously that they begin to resemble storehouses of information. So the machine responds to the operator as if it were a thinking partner. In this way, rather than merely performing the same tune endlessly, like a mechanical wind-up toy, the music-producing machine is easily manipulatable. Imagine a dream in which one moment you were playing a tuba, and then you instructed the tuba to change into a timpani, and then change into a violin. That is no dream. Through the aid of a miniature keyboard, such as you will find in a pianoforte, I will demonstrate how a performer can make this instrument sing with any number of voices, and then command the melodies to persist while new patterns are created.
Balderdash.
Additionally, I will show how all of these voices can be created from thin air, as it were, using the complex mechanism which is the heart of this machine. First, allow me to provide a cursory survey of the device. Gather. This case is constructed of heavy oak, bound in leather, and protected on every edge with sturdy metal braces and bolsters. I would not travel anywhere with this device if it were not protected from the damage. Notice, I have also fashioned a latch to secure it from prying eyes and pilferers. The top is attached with a piano hinge, and there are 4 bolts running through to hold a delicate looking glass, which I use for viewing the process of the mechanism. This I may show later. Attached to this case are 2 solid oak boxes. They contain vibrating membranes which convey the sounds that the mechanism produces. Without these, the device is as silent as a gravestone. But I can assure you that even now, and ever since I have started talking, it has been running, producing sound, and it is all communicated through these tubes, which I have disengaged momentarily so that you may hear me speak. Once I engage the circuit by connecting the switching box, it will come to life.
So much hogwash. Oh my God.
And now I am sure you're all interested in what marvels my thinking musical device will convey. If this demonstration arouses your curiosity, I will certainly reveal the inner workings and endeavor to explain them. So, without further delay, I will unlock the machine's speech. Can you identify the sound that's coming out of the speakers? Yes, it's a drum. Now, when I open this small door, I can access my miniature keyboard. And you can hear immediately the sound of an organ. Would it interest any member of the audience to learn how these sounds were made? Very well. it would be easiest for me to draw a diagram for you. So, allow me to direct your attention to this white board. In order to simplify these processes, I will represent the engines as boxes and the relationship between the engines as lines between the boxes. Imagine, if you will, that I can move these boxes around on the board and animate them as if they were the engines themselves. From here on, I will use highly technical language, which may alienate some members of the amateur engineer audience, but please withhold your questions until I'm finished, as some of these concepts may become clear as the demonstration progresses. Be sure to pick up pamphlets on your way out the door, ladies and gentlemen. Purr Data is an application one may use to formulate the codes required to create the sounds you hear. Instead of using characters and symbols, however, it uses graphical representations such as the boxes I drew on my white board. Now, imagine I can manipulate this drawing to illustrate the elements of these engines. This sliding bar increases the frequency of the oscillations from 0 to high, and the pitches increase correspondingly. Here is a graphical representation of those oscillations. And watch as I change the values in this formula. I can alter the timbre of the pitch. This is the seed of sound design. Craftspersons use this technique to recreate the sound of a horn, or a piano, or a flute. But how do you perform the flute sound? You must use a different engine. With this one, I have attached the sound creating element of the previous to a control module so that when I depress one of my keys, it opens a gate for the sound to emerge. Notice I have included a command to close the gate when the key is lifted up. But how do you automate a sound so it seems like a percussion ensemble is playing while I perform on my flute? For this, I need another module. Here. This one's called a sequencer because, as you see, I'm putting a bunch of notes in sequence. Each one of these sliders indicates what pitch the note will be. If you look down to the bottom part of this white board, you'll see that it's very similar to the last module. The only difference is, instead of a keyboard at the top, we have 17 pitch banks. And I can adjust the pitch with the slider to get a general idea of the shape of my melody, and then go back in and adjust the numbers at the bottom of the slider to fine-tune it. Every one of these little boxes has a different purpose, and this one up here changes the speed. Now that I have a sequence running, I can go down to the bottom, change the values of these oscillators. You'll notice that instead of one oscillator, I have 3. And if you have 3 oscillators, it can more easily replicate the timbre of a real instrument, like a horn or a violin. Or if you want to make a drum pattern, you can make it into a snare or a bass drum. You'll notice that I'm using the same boxes basically as I used in the previous modules, just in different configurations. And the key command up there at the top is the noise command. That sends out a little hiss that replicates the sound of a snare. And if I change this number down here from 100 to 1,000, it elongates that hiss. You can really hear it. As I make adjustments to these other numbers, I can approximate any number of other percussion instruments. A bass drum, a conga, a güiro, a hi-hat. This is how you assemble your percussion rack that you can play with your sequencer. Okay, that was fun, but it's time to get back to business. This is how I can eventually change the sound to resemble a snare or a bass drum. But again, I need yet another module for each sound. This is where Mark the Technobear comes in. This brilliant inventor has created a machine which will assemble all these instruments and processes in one interface. This should be your first stop in learning what ORAC is and how to use it, followed very quickly by a visit to the patch storage channel on Discord. These are your primary sources for learning about ORAC and how to integrate it into your system. So musicians such as yourselves can simply sit down at the console and play it like an orchestra. Alternatively, if you want to create your own instruments, just follow this address to procure your own copy of Purr Data and learn how to use it, as I did, by reading this manual located at Floss Manuals, which leads you step by step into creating your own modules. So, all these little modules, these little engines, can be enclosed in this larger one called ORAC by Technobear and used all at once as a multifunctional instrument. And this instrument is enclosed within the chest that I've been demonstrating for you tonight. I've heard others leaving, and I see that one audience member remains. Madam, would you be interested in seeing the insides of this machine?
All right.
Very well. Step up to the stage. As you see, the glass is installed in the lid, and the letterboard rests on this little shelf. Beneath the shelf, there's a magnetic latch. And the keyboard fits on this sliding drawer, which nestles inside amidst all the other machinery underneath the shelf. All these little gears and levers fit in this tiny box here. Of course, I refer to the mechanisms metaphorically. There's no way such a complex machine could fit in a tiny little box. In the box is actually a Raspberry Pi and an attachment called Pi Sound, you see? And this Pi Sound runs a special code for Purr Data and ORAC so that it can play music through these vibrating membranes that are enclosed in these solid oak boxes.
A pie?
No, I didn't mean that it's a pastry filled with raspberry filling. Of course not. That's just the product name. All this is clearly explained in the pamphlet. Here, I actually have a Raspberry Pi with me. This is what the device looks like. See? It's a minuscule calculating device. Well, we've reached the end of the demonstration. I thank you again for attending this lecture. Be sure to check the lecture notes for bibliography and further references, as I'm sure you'll have more questions now that you have seen this wondrous device. Isn't it astounding what new marvels scientific research reveals? Tomorrow, you yourself could invent the next iteration of this system or something 5 times more advanced. The only limit is your imagination.